So now in this video we're going to take another look at this DIY power supply module here. And so it's just a module. There's another one next to it. There's a little line between them. You can snap them off of each other. But I'll just leave them together for whatever reason. But in any case, right now I'm simulating an basically lithium ion battery or other lithium chemistry. 4.2 volts going to the module. So the module here, it steps up that voltage at the USB, and that's going to these two resistors, which are pretty warm right now. There's about 300 milliamps of current, actually a little less current going through them. We'll talk about that coming up. But in any case, there's a micro USB at the bottom that is to charge a battery. So I think you can run power in and out at the same time, but I don't know for sure. I haven't tested that out. So in any case, in the last video I used a single lithium ion battery in place of this power supply unit. I used a power supply to charge the battery through the micro USB. I had no problem. It stopped before 4.2 volts, which was no big deal. It was like 4.16, I believe. But when you charge lithium ion batteries to 4.2 volts, at least all the ones I got, they discharge a little bit to 4.1 pretty quickly anyways. So I don't demand 4.2 volts. But in any case, we're simulating a 4.2 volt battery here. And so I will take the meter here and show that we have here a little less than 4.2 once I get a good connection. And so that's probably resistance in the wire kind of giving us a little bit of a voltage drop. I think the unit's probably seeing about 4.2 volts. And then up here we got that jumper wire that goes over here. We'll see a higher voltage right there. So first thing we're going to do is lower the current a little bit, or the voltage a little bit. You're going to actually see the current go up. So there you can see current went up a little bit as voltage goes down. That's because right now it's stepping up the voltage by 1 volt, and to do that it needs to take some current and turn that current coming in into a higher voltage going out. So we could measure the currents and stuff, but you could see we need more total current going in, and the load itself has the same voltage across it. So Ohm's law right there, you can see 5 volts. This is a 10 ohm resistor. That's a 10 ohm resistor. So 20 ohms of resistance. It's holding 5 volts steady even as the voltage coming in changes right there. It's about 4. So in any case, we're going to go down and we're going to hit an interesting point. So I'm done measuring voltage right now. We can see there that this holds 5 volts as long as there is power applied. We can see how much current is going. So we'll just come down and look at the module now. So something interesting happens once we get down to, looks like 3.2 volts. You can see that LED is flashing right there, letting us know we're getting a lower voltage. So something interesting is that let's say we recharge the battery. We're simulating recharging a lithium ion battery. So this is made for one cell basically, but you can put a bunch of cells in parallel. You just cannot put them in series with this. As many as you want in parallel. It will just take more current to charge parallel batteries, but they'll be able to provide more current before they discharge. And in any case, you can see we still have that flashing LED even if we discharge it. And it looks like even if I unplug the load, it stays flashing. And so we will come to that in a little bit. Let's go back down. But that's kind of an annoyance. I would like it to go steady light when it recharges at least. But we're going to get to 3.1 volts. Looks like it's still going. And sometimes when I hit 3, it cuts off. And I think every time I hit 2.9, it cut off. There you can see it cut off. There's no current flow. And so, again, we got that annoyance. It went off. It's staying off, even as we recharge the battery, simulating recharging the battery. So, what we gotta do, unplug this, and looks like it might have to be about 5 seconds. I kind of plucked it off and quickly put it back on earlier, and it did not turn on. But first you can see the current go on, and then you can see the LED go on. And so now it is on. Now let's cut off the load. So we'll watch there. Looks like that's the current needed to have the unit do whatever it's doing and leave the LED on. Once the LED goes off, I like this. It looks like there's no current flowing. So there may be a trickle, but it looks like practically none. I reattach the load, and now we got current again. So who knows how much energy that's draining. Of course, that's no problem with the power supply, but if you got a battery there and it's draining some energy, it's going to discharge the batteries over time. So that's something to be aware of. More testing for a later video. But in any case, problem I had in an earlier video was when the 18650 battery, I just used a single crappy one because it doesn't store much energy. It's a knockoff, and so it can quickly discharge and charge, and I can do a lot of testing in a short period of time. But while I was discharging it, I was getting less than 2 volts being measured. And that was, well, it was powering these resistors. And so it was pulling the voltage down because it couldn't provide much power without its voltage dropping. But soon as I took the load off it, its voltage went up to like 3.7 volts. So it was acting all kinds of crazy. But we're going to go down to about 3 volts. Let's try 3.1. And so when we're at this position, basically with the 18650 battery, the LED was flashing and everything, but this was saying the meter, actually. I was measuring this point here with the meter. Now remember, I'm talking about when I was using the 18650 battery, and I had 6 volts or something. And there you can see when we get a good connection, we have like 3 volts. So I don't know if there's something wrong with my testing. You know, I may have had like voltage loss somewhere for some reason or something. That may have been the problem. But I was getting a lot lower voltage than 2 volts. So that was a problem. And I suspected my module was letting the voltage of the battery drop down. But when we test with the power supply, we don't see that problem. This is still good. You can discharge lithium ion batteries. You don't want to keep them at 2.5 volts, but if they get to 2.5 volts, that should not be the end of the world. But ideally, you should stay between 3 volts and when they're discharged, and then 4.2 volts when they are charged. You don't want to go above 4.2 volts, and you don't want to trickle charge at this point. Once you charge it to 4.2 volts, then, and you can see the module is still off. So let's try that quick disconnect, connect. See if that was too short. But earlier it did not turn on, and I think it would have turned on by now. But in any case, we'll give it plenty of time to see. But once you charge it to 4.2, it's going to kind of droop down afterwards. So you don't want to trickle charge it. It looks at how long you charge it as part of it wearing down. So you want to charge it fully and then discharge it, because if you keep trickling current into it, that kind of wears it down. So let's unplug that for like 5 seconds or so. Now I'll plug it in. Now the unit should turn back on. So this is a new unit for me. I'm getting more of a feel for it, but I really want to figure out what went wrong with that other battery before I start trusting this with protecting batteries. And but in any case, with the unit here, I'm a lot more confident that it is working all right. I was worried maybe I fried this one or something, so I was going to start testing like another one if we also failed with this voltage test. So we'll see what we do later on. But in any case, I learned a lot about this unit today. I showed everything that I learned, and also my earlier video with the battery. I learned a lot in that video too, and I showed it all there. Most of that I learned while I was filming. So in any case, it's a pretty cool unit. It's about $1 if it works right, and it looks like it can handle about 1 amp of current, but you can take as many batteries as you want in parallel, so you could power things for a long time at 1 amp if you put a lot of batteries in parallel. So in any case, hopefully you found that interesting. Thanks for watching. I'll see you in the next